demo, what we have right now is essentially the representation of a data pipeline, which is very, very common inside a modern data enterprise. What you see over here is that this is a fairly simple data pipeline, which shows how data is getting created inside an S3 location written down to RDS. And then we use a Databricks job to move all that data back into Snowflake. So essentially, Databricks is being used as the ETL tool. Snowflake is being used as the final repositories, and then there are files in between. Now, as you can see, this was expressed in Airflow, and we've provided our SDK for integration over here, which allows data engineers to go and log all the critical events that they would like to log, and in addition to that, create the events that are of interest that may be useful from a production and operations point of view. What we do inside the product called Acceldata Flow is essentially represent the same data pipeline, but make it data aware. So if you look at this, the red boxes are essentially representing all the different compute jobs, whereas all the green boxes are essentially representing all the data elements that are associated with these compute elements. And as you can see, these are essentially the intermediate RDS tables, while these are the S3 locations where we are creating these jobs, which are then finally getting merged, and we are creating a table out of it. If you look at what else we have on the screen is essentially a representation of how much time did this pipeline take on an ongoing basis, repetitive views of how it has been doing from a performance point of view, if there were any failures, when was the last time that this pipeline failed and what were the causes, and if you wanted to do a comparative analysis, you will be able to see the reasons why some of the pipelines have slowed down, and you can go back in time as far as you can go. The other thing which is very interesting is that we allow developers, data engineers to go and log all the information. So now, as you can see, there's a complex data pipeline, which is a multi-technology data pipeline, which is moving data, from the point of consumption, or point of origin to the point of consumption using different technologies. We have logged information available, which shows what are the errors which occurred along the way. Any information about metadata, all the different, information details about what query ran, what time did it start, how much time did it take. So all the operational details are available right here. In addition to that, you also have the capability of not just looking at the operational details, but you can also start looking at, what data was processed. When was this data last profiled? What kind of data policies were configured? Was the reconciliation policy configured on that data element or not? Is there a data drift policy? And is there a warning that we can see from a data drift perspective, looking at, is the data the same that we had assumed it will be when we were either training our models or creating these analytical reports or operational reports for people to go and consume? And if it has changed, how has it changed? And that detailed view is available inside the capabilities that we have provided inside, Acceldata Torch overall, which gives you not only the view in terms of, what data elements exist, but in a complete 360-degree fashion, which talks about not just profile, but also tells you how the data quality is, talks about things such as automated anomaly detection, and gives you an entire or a complete view in terms of what data elements are you using today. Now, one of the things that I am going to cover is where did this data come from? But before that, let's look at things like quality. Now, as you can see, this particular data asset has two kinds of rules configured against it. One is essentially a simple rule which says that whether data is changing or not. So as you can see, no data elements have been added, the DMLs have not been applied. But if you look at where it is receiving data from, as we just saw from the pipeline, this data table is receiving data from several other data sources, and we're trying to do a reconciliation between the amount of data that it should receive versus the amount of data that it actually has received. And as you can see that from an equality point of view, this has been consistently failing. Now, every time a failure occurs, the same error message is sent over different channels, which are very operational friendly. You can essentially configure it using Slack channels, Jira messages, Inbox, ServiceNow, or you can actually integrate with API. So one of the critical elements of our differentiation from a product point of view is that the entire feature set, everything that is visible here and more, is available via APIs. So one of the things that we are encouraging data engineers to do is to actually go use all of these APIs and integrate inside their own data pipelines and use all of this information to build circuit breakers, which allow them to manage and monitor their data pipelines a lot better than they would otherwise. In addition to that, we've got things like automated anomaly detection. So you don't have to actually configure quality rules. We automatically understand the trend and the pattern of data. And we tell you that, here is where we feel that, you have had data elements which don't fall into the bracket that you assumed it will. And therefore, you should actually consider looking at these data elements, even when you assume everything is okay. We've already identified that there have been anomalies. In addition to that, identifying what are the different relationships in which it occurs. Where is the data asset placed? What is the provenance? What is the lineage? Where does it exist in a physical space, in a logical space? What kind of lineage can we look at? For example, where was this table created from? Now, just like we saw earlier inside Acceldata flow capabilities, that the data pipeline, the processing pipeline is data aware. In this case, the lineage is processing aware, which is a very, very unique feature that only Acceldata provides as of today across a host of different vendors. So what we have over here is that not only does it have the view of where, what the antecedents or what the provenance is, but it also tells you about, which jobs ended up creating, this complex hierarchy of tables. And, as you can see over here, it clearly says that, the data quality is failing. So in one view, you get the entire picture. Now, the final part of the demo is actually about monitoring, how you are doing in terms of your compute infrastructure, which we were talking about. The compute infrastructure actually can talk about, since we're talking about, jobs which are Databricks specific. If you wanted to look at the Databricks job, which was used in order to create this particular table, you can actually click on the details of that particular job and look at how has it been performing historically. From a comparative standpoint, whether these jobs have been running on the Databricks infrastructure in the right amount of time, if they were configured from a concurrency point of view with the right number of executors, did it have the right ideal time? Did it use the right amount of cores? Did it have the right amount of processing power? How was it scheduled? How did the executors run? And most importantly, were we using the cores in the right way? Because Databricks is pretty expensive, and so are several other compute infrastructures. But are you spending the right amount of money at the right place? So finding out to the final level, which is what we were speaking about earlier, is finding out whether you were able to identify through a correlation mechanism, starting at the data pipeline, going all the way down to the infrastructure and compute level, and finding out whether the entire data pipeline was functioning appropriately or not. So with that, I think we've concluded this demo, and we can obviously get into a lot more detail because we have got a lot of content to publish from a compute framework or from a data quality or pipeline perspective. But for the purpose of this demo, I'll just stop here.